Hello students, I am Dr. Sumit Majumdar. I am a pass out of IIT Delhi from the 2003 batch, and since then I am with the askIITians. Today we will be starting to learn about the laws of motion. So what are the laws that govern our everyday life? What all do we see around us? How do these things move? How do these things interact with each other? That's all we are going to learn in this particular chapter. So I'll be introducing this and then I'll be describing the whole laws of motion into different parts. So hope you will enjoy with this. So laws of motion basically can be bifurcated into these parts. We can say that introduction, balanced and unbalanced forces. So we'll basically introduce the topic to you first, then we'll further bifurcate and understand what are basically known as the balanced and the unbalanced forces. How do you differentiate about the two? Going further, we'll say that once we understand about the balanced and unbalanced forces, then we'll go further and try to talk about the law of inertia. So inertia is the first law basically, but we have segregated it. Then if we go further, once we are done with the Newton's first law of motion, we need to move over to the Newton's second law of motion. That will be followed by the Newton's third law, and finally we'll go over to the conservation of momentum. Obviously there will be interweaving chapters that will be discussing as well, interweaving topics that will be discussing as well. So try to be tuned in. So with that we start off. So when we start off with the first thing, that is introduction. So introduction to the law of motion. So Aristotle first introduced about this. So according to him, what he said that if there is a body that is moving, in that case there should be some external force that is required to keep it in motion. So there has to be an external force which has to keep the object in motion. So according to the Aristotelian thought, what we'll say that an external force is required for keeping the body in motion. So here as we see that the two forces that are acting, here is the force that is being acted by the persons, and let's assume that this is a kind of an opposing force which is acted by the surface of contact. So when these two forces are equal, in that case there are not going to be any motion, as we'll see later on. When either of the two forces is going to be more, that is going to produce a motion. Yeah. So taking it further, we try to define what exactly is a force. So force is nothing but a push or pull that is being acted upon an object. So a force given to an object basically provides it an energy which causes the object to start moving. It can even stop the motion of an object or the change in its motion. Change its motion in the sense that if the object was moving at a lesser speed, its speed can be enhanced or its speed can be decreased, right? Even its direction can be changed. So the force can do all these things. Then if we have to define further, we'll say that the forces generally occur in pairs. That is, it can either be a balanced force or it can be an unbalanced force. When we talk about a balanced force basically means that the forces are equal, they are opposite and equal in nature. When we talk about an unbalanced forces are going to be opposite but unequal. So here as you can see, when we say that this is a balanced force, here this force is equals to this force, and therefore these two forces are equal in energy. When we talk about unbalanced forces, so unbalanced forces as you can see are not equal. So therefore there is a resultant force coming out as a difference of these two forces. Yeah. So these two forces are going to be unbalanced in nature. So let's take it further now. So when we talk about balanced and unbalanced forces, so here as you can see, the force that is being acted by the person is equal to what we say the force of friction, that is the opposition to the motion of this object. So when these two forces are equal, in that case the object does not move. So we can safely say that these two are balanced forces. Whereas in this case, if either of the two forces, let's say the force that is being acted upon by the person is more than the force of friction, that results into a net motion of the object. So this is what is known as an unbalanced force, right? So we have differentiated between the two forces, that is a balanced force and the unbalanced force. Let's take it further to discuss about balanced forces. So balanced forces are those forces which do not really cause any change in motion, for the simple reason that the net result is zero. They are equal in size and obviously opposite in direction. They act oppositely and their magnitudes are exactly the same. That's the reason we say they're equal in size and they're opposite in direction. Let's try to take an example. If you say that you have a wrestling competition, you come across a wrestling competition where both the competitors, both the wrestlers are equally strong. So if they're equally strong, in that case, both will be pushing hard on the other person, but still there is not going to be any motion of their arms. So as you can see, both of them are pushing each other. They are exerting forces, but still there is no motion taking place. Why? For the simple reason that both of them are exerting equal amounts of forces. So this is an example of balanced forces. So you can see that the force exerted by each person is equal, but they're pushing in opposite directions. Therefore, this is what you will get. Now, taking it further, we'll say that as the force that each of them are exerting is equal, the two forces are going to cancel each other out. So there is not going to be any resultant value, and therefore there is no change in motion that is going to take place. Similarly, what you say that, let's say we talk about the case of a tug of war. So in the case of a tug of war, here there are going to be two teams which will be trying to pull the rope. To win, they have to see that their force is more than the opposing team. So here, as you can see, both the teams are pulling the forces, pulling the ropes in opposite directions. Now for them to keep on the stress on winning, in that case both will try pulling the rope such that none of them fall down. Whosoever falls down is going to lose it. Therefore, in this case, the resulting force is 0, even though both the teams are exerting forces and there is no change in motion taking place. Yeah? Okay. Unlike the case of balanced forces, the unbalanced forces obviously will cause a change in motion. They are not going to be equal, but they will definitely be oppositely directed. So when two unbalanced forces are exerted in opposite direction, in that case their combined effect is equal to the difference between the two forces. The combined effect is such that it is equal to the difference between the two forces and is exerted in the direction of the larger force. So whichever is the larger amount of force, in that direction the combined force is going to be produced. Right? So here, if you take the case of a wrestling match, but one wrestler is going to be, let's say, stronger than the other, in that case the force is going to be bigger than the other force. So there is going to be a net value of resultant force. So for instance, this wrestler is not that strong enough to compete against her opponent. Therefore, this wrestler wins. So this is a case of unbalanced forces, right? Now let's try to take it further. So this can also be taken further when we say that you have unbalanced forces which can be also exerted along the same direction. So when you try to exert along the same direction, there is going to be a net production of force. So how will this work? Let's say you are trying to push your car alone, but you are unable to do. But supposing your friends also help you out in trying to push the car, you are able to move the car. So what is the result? So in this case, the net force is going to add up. The two forces, two combining forces are going to add up to give you the resultant value of the force. So here there are two unbalanced forces, they combine to give you the one bigger force. That is a result of motion. So what we should remember, so the points we should remember when working with balanced and unbalanced forces: when you have forces along the same direction, they are going to combine. When they are in opposite directions, they are going to be subtracted out. So if they are along the same direction, you need to just add them up. When they are in opposite directions, you will be subtracting. Yeah? Okay, so far so good. So going further, if we have to now define about the net forces. So let's define a couple of cases. So here, let's say the body is starting from rest, as can be seen from this. We don't need an explanation. So we can see that as time passes on, the body is covering unequal distances in the same intervals of time. Here the body is covering equal distances in all equal intervals of time. In this case, the body is again covering unequal distances. Similarly, if we try to plot in terms of velocity time graph, so we have these three. So in the first case, as you can see, the velocity is increasing with time because the distance covered increases with time. So obviously there is a force acting. In this case, the velocity remains same at all instants of time, so there is no force acting. Third case as well, the velocity decreases because the distance covered decreases, so there is a force acting. So if we try to take it here, so in this case, velocity remains constant with time, so there is no force acting because acceleration value is 0. If we try to talk about here, in this case the velocity is decreasing, that means there is something known as retardation, the body is slowing down. So when the body is slowing down, there is a net force acting. Similarly, when we say that the velocity is increasing with time, we will say that there is a force acting. This is clear? So now if we take it further, we try to understand about what is known as a free body diagram. So what exactly are the free body diagrams? So if we say that we have a book that rests on a tabletop, so here the normal force is going to be balanced by the gravitational force of its weight. So these are the two forces that will be acting. So even though you may feel that the book is at rest, there are forces acting. The two forces are going to be balanced, so that is not going to result into anything which is not going to move the object, but still there are going to be forces acting. Similarly, if we say that there is a girl that is suspended motionless from the ceiling, so we'll say that this is the case. So it is not looking like a girl though, but let's assume that it's not at all, it's a girl. So here, as you can see, there are two ropes which are keeping her intact in her place, and she would be obviously having her weight. Therefore, the tension force is going to be, there are going to be two tension forces which are going to be balancing the gravitational force. Yeah. Then, if you have an egg that is freely falling from a nest, obviously there is no balancing force. The air resistance is not considered, so the air resistance is not considered. So there is no balancing force. So the egg obviously is going to come down. So there is only one force acting. So this is an unbalanced force that is acting on it. Let's take it further. If you have a flying squirrel which is gliding from a tree to the ground to constant velocity, so if you do consider air resistance, obviously the air resistance is going to be the one which is going to be opposing its weight, or it's going to be balancing its weight. So the air resistance is going to be balancing the weight that the squirrel will have. Taking it further, if we say that we have a rightward force that is being applied on a book such that it moves across with a rightward acceleration, you can see that this is mentioning rightward acceleration. That means the net force, there is some amount of net force. So even though you consider frictional forces, the net force is going to be more than the friction force. So as a result of this, the object moves. If we take it further and say that the rightward force, everything remaining the same, but the object moves, or the book moves with a constant velocity. So if the book moves with a constant velocity, in that case, what we'll say, if we just neglect the frictional forces, in that case, the applied force is going to be balancing the frictional force, and it's not going to be any motion taking place of the object. So all the forces are going to be balancing each other. Let's take it further. We'll say that a college student rests a backpack upon his shoulder. The pack is suspended motionless by one strap. So obviously that one strap is going to be taking the complete weight of the of whatever is contained in that. So that there is going to be one tension force which is going to be balancing the gravitational weight. Next, if you say that there is a skydiver who is descending with a constant velocity, so if you consider air resistance, so the air resistance is going to be balancing the gravitational weight. Finally, if we say that there is a force that is applied to the right to drag a sled across a loosely packed snow, so there is a rightward acceleration. So in this case, if you do try to find out what all are the forces that are acting, so the applied force is going to be more than the frictional force of the snow, which is going to be very less, and they are going to be balancing each other. And since the person does not fall down, so the normal force is going to be balancing the gravitational force. Yeah. So this tells us about how do we understand about what all are the forces that are acting on an object, right? Now we move in our next topic about the laws of inertia. Till that time, I end it here. Thank you. So students, we understood about the introduction to the laws of motion. We understood what all are the forces, what all are the kinds of forces that are required, and what all do we need to understand in this particular thing. So have you ever wondered Supposing you are sitting in a car and the car starts suddenly. In that case, what is the kind of force that you feel? What is the kind of sudden reaction that you feel? Let's try to understand more on this in our next topic, that is the laws of inertia.